Hello, in this video we will talk about how to solve for the zeros of a function. So here you can see that I have an equation all set up and I want to solve for certain zeros. Now when you put the equation in, you're going to go ahead and graph it, and if you see your screen as something that you don't like because you can't quite see the zeros, you're going to have to modify your domain and range. So one option is you can go to window right here, and then you can modify it too. One other option is that if you go to the zoom function right here, you have a list of all the possible setup that you can actually want. Normally, if you wanted your setting to be from -10 to 10 for the domain and range, you go to standard and it'll actually automatically take care of that. But just in case you want to change it according to what you like, it's probably best that you go to the windows over here. So let's go ahead and change it right now to something that is closer to the zeros that I have. In this case, let's say from 0 to 10. And let's say that the y values are going to be from -5 all the way to 5. So let's see what the window looks like. And you can see that we actually have some zeros right there. Now, since there are 3 zeros in this window, we have to specify which one we need to solve for. So if I push the trace button, you can now see that there's a little cursor right there that you can follow along the curve. So for example, let's say I want to solve for maybe this 0 over here. So what I'll do is I'm going to get close to it just to see what the value is approximately. And if you look at the numerical value, it looks like it's around 6 then. So next, what we'll do is we'll go to second and then calculate. And then we're going to go to 0. And at this point, you're going to be asking the calculator where to look for the 0. So we're going to look for a left bound. So that means you need to bound the 0 on the left. So go somewhere a little bit on the left and push enter. Notice that there is a vertical line over there. So that means that the graph will never look to the left of that vertical line. And similarly, now it's asking for a right bound. So you need to go to the right and then push enter one more time, and that'll give it a vertical bound on the right hand side. Now the calculator knows to look within those two vertical lines then. The final item that it tells you to do is guess, and the reason why that's there is, well, what if your boundary contains more than 1 0? So you have to tell it where to look to. So this one, if you only have 1 0, then it doesn't matter. You could just push enter. But if you have more than 1 0, then you have to move that cursor as close to it as possible. Finally, I'm going to push enter one more time. And there we go. There's your 0, which is going to be 6.2833, whatever it is. Okay. One other thing that I want to show you is that let's say that I want to solve for the tangent slope at a certain point. Your calculator can actually do that too. So if you go to second and calculate one more time, and if you go to the sixth option right there where it says dy divided by dx, that will allow you to solve for what the tangent is at any instantaneous point. Now in terms of what that represents, that is what is called the derivative, which we will look at in the near future. So right now I'm going to go ahead and just select that option. So enter, and we're going to go ahead and plug in the value that we want to solve for the slope at. So let's say at -6. Or actually not -6, but +6, because we're within the domain. So I'm going to go ahead and push 6 right here. And then we're going to push enter. And there it is. The slope is approximately -0.839 then. Okay, so that should take care of everything you need. Have a good one.